Hi everyone, today's lesson is about the first derivative test. Last time we saw that when the derivative is negative, the original function is decreasing. And when the derivative is positive, the original function is increasing. For example, let's look at the graph of y equals x squared and its derivative y prime equals 2x. Where the original function is decreasing, the derivative is negative, and where the original function is increasing, the derivative is positive. But what if we don't have the graphs? How can we see this algebraically? That's the point of today's lesson, is being able to see what's going on just doing algebra. We can investigate the derivative using the first derivative test to determine the increasing and decreasing nature of the original function, as well as find the maximums and minimums of the original function. Let f of x equal x cubed minus 3x squared minus 9x minus 1. Our job is to figure out where the derivative is positive and negative, and then assess the information. First, find the derivative. F prime of x equals 3x squared minus 6x minus 9. If I want to know where f prime of x is positive and negative, I should first figure out where it is 0 or doesn't exist. So let's solve f prime of x equals 0. That is 3x squared minus 6x minus 9 equals 0. First I factored out a 3, and then I factored x squared minus 2x minus 3 as x minus 3 times x plus 1, and set each of those factors equal to 0 to get x equals 3 and x equals negative 1 as the places where the derivative is 0. But feel free to use quadratic formula if you can't factor, or even a computer is fine. Next we make a real line, and we're going to track the y values of the derivative. So I always make sure to mark negative infinity and positive infinity, and then mark wherever the derivative is 0, in this case negative 1 and 3. So if the derivative is 0 and negative 1 and 3, it must be positive or negative in each of the intervals. Thus, we only have to plug in one test value from each interval to see whether the derivative is positive or negative. So for the first interval, I'm going to plug in negative 2, because that fits in the interval, and I got the derivative was positive. For the second interval, between negative 1 and 3, I plugged in 0 into the derivative and got that it was negative. And in the third interval, from 3 to infinity, I plugged 4 into the derivative and got that the derivative was positive. So I'm going to update my real line and show that where the derivative is positive and negative. And then we can draw conclusions about the original function from this first derivative test. So we can say that the original function f of x is increasing from negative infinity to negative 1. It's decreasing from negative 1 to 3. And it's increasing from 3 to infinity. Okay. So I just made a little sketch of f above and just showing f is increasing, and then it's decreasing, and then it's increasing from the first derivative test. So that tells us that the function has a local max at negative 1 and a local min at x equals 3. And here's some little graphs of these functions, and you can see where the function is increasing, the derivative is positive; where the function is decreasing, the derivative is negative. Let's do one more example together. Given f of x equals negative x cubed plus 3 halves x squared plus 18x, find where f is increasing and decreasing, and find any local maximums or minimums. So first let's find the derivative. F prime of x equals negative 3x squared plus 3x plus 18. So we want to first see where the derivative is 0. So set the derivative equal to 0 and solve. This one I was able to factor and get x equals 3 and x equals negative 2. Okay. And so I made a real line graph for f prime with negative infinity, negative 2, 3, and infinity, and then I'm going to test one value from each interval. In the first interval, from negative infinity to negative 2, I plugged in negative 3, because that fits in that interval, and plugged it into the derivative and got negative 18. So the derivative is negative on that entire interval. Then the next interval, from negative 2 to 3, I plug in some value in there. I plugged in 0 into the derivative, and I got the derivative was positive, so that whole interval, the derivative is positive. And for the last interval, from 3 to infinity, I plugged in a number 4, which is in the interval, plugged it into the derivative, and I got the derivative was negative, so that whole interval is negative. So I've finished the problem by filling in the negatives and positives into the real line for the first derivative. And then I can see the function is decreasing from negative infinity to negative 2, and also from 3 to infinity. The function is increasing from negative 2 to 3. And I can see that then the function must have a local min at x equals negative 2, and f of x has a local max at x equals 3.